Alright, like I mentioned on the front part of this, we're going to be able to use those different sums for the interior angles for different polygons to figure out some of the unknowns. So in this case, we have a quadrilateral, which recall, if you want to take a look at the figure really quick, if I were to draw a line, the only thing that I can create is two triangles. Alright, since we have two triangles on that figure, two triangles is going to imply that we have 2 times 180 degrees, which we know is going to be 360 degrees. Now this is the one where I expect you kind of just to remember that one. Quadrilaterals we're going to work with quite a bit. So for a quadrilateral, 360 degrees for the sum of the interior angles. Which means that if I were to add all 4 of these interior angles up, they would have to equal that 360 degrees. So let's go ahead and set up an equation where we add all 4 of those things up and we make it equal to 180. So I'm going to write down x plus 71 plus 112 plus 135, and we know if we add all those up, the sum of the interior angles for a quadrilateral is 360. Okay, so that's the equation we start with. Now we can go ahead and we can simplify it, and then we can solve for x. So let's group all our like terms. We have these 3 like terms we're going to group together. If you were to type those in your calculator, add those up, you would get x plus 318 is equal to 360. Alright, lastly we know that we need to subtract the 318 on both sides to get x by itself. And we find that x is going to be 42. Okay, so that is a 42 degree angle right there in order to add up to 360 degrees for that quadrilateral. Let's take a look at another example where we can do that. This time we will take a look at a pentagon, a 5-sided figure. Now, I could just use my equation and just get the 5 minus 2 times the 180, but just to show you really where that's coming from one last time, we can create 3 triangles. Okay, so typically I just expect you to use the equation, but I want you to recognize too, really that equation comes from the fact we have 3 triangles. Alright, so 3 triangles implies that I should just take 3 times 180, and we know that the sum of the interior angles for this pentagon is going to be 540 degrees. Alright, again, so what that's going to tell us that we can do is that we can add all of these angles up, all 5 of them, and it should equal 540. Now we don't know K, we don't know L, we want to find both. Now the nice thing is they have a common marking, and the common markings show us they're going to be the same thing. So what I'm going to do is I'm going to put an X in place of both of those. And we know the measure of K and the measure of L will be the same thing. So let's set up our equation. We're setting everything equal to 540 once we add those things together. So I have X plus 68 plus 105 plus 109. And again, that equals 540 degrees in total. Okay, so adding all those things up. Once we simplify it, we get our x's together. That's a total of 2 x's. We get all of our numbers together. That's going to give me 282 for those 3 angles that we do know. Okay, 282, and that equals 540. Alright, now in order to solve, first thing we want to do, we got to subtract the 282 from both sides. So let's go ahead and do that. Okay, so now we're left with 2x is going to be equal to 258. Alright, our very last step is going to be to divide by 2. And we find that x is going to equal 129. Alright, so for the measure of angle K and the measure of angle L, well, we had an x in both those places. So we know that both of those are going to be 129 degrees. So the measure of angle K equals 129 degrees. The measure of angle L equals 129 degrees as well. Okay, so we could use this for any number of sides. And you wouldn't always have to do this. You could just use your equation to figure out what the total sum of those interior angles is going to be. Again, the reason why I showed you this is to show you where that equation comes from.